This video will be on periodic table, on how to use a periodic table and how to refer to it. So you will be given a periodic table in your exams. Okay, so from a periodic table, what can you find out? You can know the group. So these are the group numbers: group 1, group 2, group 3, group 4, 5, 6, 7, 8. So for example, what group is boron in? So boron's in group 3. Okay, and the other way, this way, horizontal is the period. So there's period 1 here. It's a very short period, just hydrogen and helium. And then period 2, period 3, and period 4. These are our focus. Of course, there's period 5, 6, 7, but our focus is still period 4. Okay, what else can we find out from periodic table? We will know the atomic number, which is equivalent to the proton number. So how many protons are there in each of these atoms? You would know from the atomic number. We know the atomic symbol. So the symbol, remember, the first letter has to be capital and the second letter is in the lowercase. Okay, if there's only one letter like carbon, C only, it's definitely caps. Okay, so capital for that. So no mark for writing a small n for nitrogen. That's not the symbol of nitrogen. Okay, it has to be a capital N. Okay, that's the symbol. And the names, make sure the spelling is correct because you're given the whole reference, the whole periodic table here. So don't make a spelling error. So the name is given here. And the bottom, the larger number, is the relative atomic mass, which is the mass. Where did the mass come from in an atom? So in an atom, the middle, we call it the nucleus. And surrounding this is the shell. So inside the nucleus, there are some protons, this proton, and there are neutrons. Okay, protons and neutrons are the one that gives us the mass. Okay, so let's put it in the table. Protons, neutrons, electrons. What is the mass? And what is the charge? I hope you still remember. So all the mass, I tell you, it's in the nucleus. So who's giving the mass? Who's having all the mass in the atoms? It's the nucleus where the protons and neutrons are. Okay, so protons weigh 1 relatively. So there's no unit because it's a relative thing. And neutron also 1. Electrons almost nothing, is 1 over 1,800. So it's so small that it's negligible. We can just assume that it's like 0. Okay, so in an atom, it's neutral. So the negative and positive must neutralize each other because a negative and a positive thing will attract each other. So each atom, you see, there's no positive or negative, meaning the protons and the electrons must be balanced out. Okay, so protons, they are positively charged. Electrons, they're negatively charged. And neutrons, they got no charge. Okay, so if protons is in the nucleus here, where are the electrons? The electrons are out here in the shells. So if I draw 3 electrons here, I'll have to draw 3 protons here. So it means 3 protons attract 3 electrons, which is why they have no charge. There's no positive or negative in an atom. So if someone were to ask you, what is the number of neutrons in lithium? Okay, so we know that lithium weighs 7. And out of that 7, 3 is the protons. So this is the mass. 3 is the protons. So what is the rest of the mass? That 4 would be the neutrons, because electrons has very little mass, 1 over 1,800. It's almost nothing. So the rest of the mass must have came from the neutrons. So take the larger number at the bottom, minus the smaller number at the top, you will get the number of neutrons. Okay, how do you find the number of electrons? So all this in the periodic table, they are atoms. If they're atoms, then you would know that protons, number of protons will be equal to number of electrons. Okay. Because they have no charge, there's neither positive nor negative in any of these atoms. So the protons and the electrons has to have the same number so that you all balance out each other. And the mass must come from the protons and the neutrons. Electrons doesn't give any mass.